Hello. In my next three videos, I will be getting into a series of three formulas, really very important formulas, that would be uh, that would work in the absence of a 90 degrees being seen in the right angle triangle. Now you know well enough that the prime essential of trigonometry is having a 90-degree triangle. But this is what we really expect. If I were to show it to you, we expect this: a triangle with a 90 degrees. But would trigonometry not work if there is no 90 degrees? Sine, I should specifically say sine. Would it not work if I have a triangle which is maybe something of this kind? Yes, it can work. All you got to do is create a perpendicular. So how do I do that? I simply drop a perpendicular from the vertex downwards. And there, you have two 90-degree triangles inside. This is the first one, and in the neighborhood, you got the second one. So trigonometry can still work. So it's on this basis that I'm going to make this uh, three formulas. One that will be called as the sine rule. The second that is called as the cosine rule. And the third, which is called as the area of a triangle. So today I'm going to work on the sine rule. Try to derive that for you, or in fact, try to derive that for you, uh, and try and what we're going to try and do together is try and make a statement out of it instead of remembering just as a formula. Okay, that's what we're going to try and do. Well, let's go on. I have this triangle. Let's take this over here. And let's call these vertices as A, B, and C. We generally have a way of working in which we try to keep the opposite side of the vertex with a small letter A, the opposite side of the vertex B as a small letter B, and the opposite side to C as a small letter C. We wish to associate these angles, okay, the angles over here and the sides by a trigonometric relation. There exists such a relation. That's what we're going to see now. I'm going to drop a perpendicular to begin with from C downwards, creating the 90 degree that we need. Let me call this as the height of the triangle, H. Okay. Now, I'm going to associate, if you realize, the two triangles. Okay, I'm going to call this point as, say, some x over here, the vertex, the perpendicular as x. Okay. And therefore, you may realize that sine of A would be equal to h upon B. And at the same time, sine of B, okay, that is this angle, sine of B would be again be equal to h over A, because it's the opposite upon the hypotenuse. Now I do realize that there's an h which happens to be a common chain between the two ratios that I created of different angles. So I'll make them as a subject. Therefore, I'm going to have h over here to be as B times sine A, and h over here is A times sine B. We can equate the two of them. Therefore, B times sine A is equal to A times sine B. can create a ratio out of it, make it more simplified. This is the primary form. Okay, I can make a ratio out of it. So I'll be having sine A over A, dividing by A on both sides, would be equal to sine B over B. Okay, that seems pretty cool. Sine A, sine of the angle A over its opposite side A, is equal to sine over sine of the vertex B, the angle at the vertex B, I'm sorry, divided by the opposite side, that is B. Similarly, we could go ahead and find, you could go ahead and prove that uh, the sine of B over B would be equal to sine of C over C. You can try this and see. So putting it all together now, it'll come to a conclusion that sine of A over A would be equal to sine of B over B, which is equal to sine of C over C. We can take two at a time, any time that we need whenever you're working on our problems, and create solutions. So this rule that we see over here is called as the sine rule. This is called as a sine rule. Now, I don't want you to just give up by knowing this formula as a or a B or a C. I want you to generalize this. Now, what do you see over here? Now, remember the triangle. So, sine of A, so if you can just put that into words, it'll be wonderful. Take a minute to do that. So, if you tried on that, you could say that sine of the angle to the opposite side is equal to sine of any other angle in the triangle, of course, to its opposite side. Okay, now I just spoke for two of the ratios over here, but that's what it means for the third one too. Let's try this out and see as an example, and it makes more sense when you work with an example. So let me put up this triangle. Let me just confirm that. Okay, so I have this triangle. Let's see what use could this be for. Let's say that this side over here is, say, some 4 centimeters. This is 7 centimeters, and this, and let's take that the angles over here is say some 30 degrees. I'm sorry, this angle over here is 30 degrees opposite to the 4 centimeters, and I wish to find the angle opposite to the 7 centimeters. Let's call this angle as, say, X. Now, this is what I check on. I got angles and side. So how do I work on this? So let's say this. So I have sine of, so I'm doing it without any letters as A, B, and C, remember. I'm trying for that. So I'll be having, my information now is about the 30 degrees. So I see that sine of 30 degrees divided by its opposite side, that is 4, should be equal to sine of x degrees divided by its opposite side, that is 7. Therefore, I will be having sine of x. I like to make x as a subject. Therefore, sine of x should be equal to 7 upon 4 times sine of 30 degrees. Therefore, sine of x degrees would be equal to 7 upon 4 times sine of 30. If you use your calculator, sine of 30 would be a 0.5. So I'll be having sine of x degrees would be equal to 7 over 8. And therefore, x, the angle that we are wanting, would be equal to a sine inverse. Remember that this negative 1 is not uh, a power, unlike in indices. Okay, always remember that the negative 1 is not a power. So that becomes sine inverse of 7 over 8. 7 over 8. Now take your calculators and try to see what could be the value for sine inverse of 7 over an 8. I hope you have got that. And that should be approximately 61. I did my work, and that's approximately 61.04 degrees. But we try to leave our answer with one decimal place. That's a requirement of the general boards that we have. 61 degrees. 10 degrees. Okay. Look back into the work, review through that. Okay. Always remember the sine rule. Try to speak that in simple general words instead of using letters. It'll make more sense to you, and it'll be more stronger in your mind. Okay, just take that little time to put that into words, express that in words. Okay, that's a suggestion. Thank you.